Saxon's Trig lesson 43, beginning on page 308, is about periodic functions and then the graphs of sine and cosine. So part A is basically introducing you to what happens when and I've alluded to this before, when they showed you that last circle lesson and they did triangles and they kind of rotated them and they were trying to say that the right triangle rotated around on the 4-quadrant graph gives you a circle, because you've got a peak here, a peak here, a peak here, a peak here, and then basically when you're connecting them, you're getting that circle. So now in a periodic function, what we're doing is we are slicing here and unraveling this. And so the circle gives you a part that's in the positive half of the graph and a part that's in the negative half of the graph. So these two quadrants and these two quadrants. And when you're unrolling it, you're creating a curvature. They don't get into all of this, but basically this curvature would continue as if it were a car wheel rolling and rolling and rolling. And so it's creating a wave of some sort, where from here to repeat, that's one period, one rotation, and then again here. And so anytime you're getting curves in waves like this, you're talking radio waves, audio waves, radio waves, light waves, all of that is based on this. And so this is where trig gets really applied into those kind of applications. But for right now, what you want to focus on is, how do I graph one of these lovely periodic functions where the period is one rotation of unrolling that circle. So part B gives you the graphs for sine and cosine. They go into their own explanation as to how this stuff works. They continue it on 310. They're showing you the triangle inside a piece of the circle, and then they're trying to show it to you unrolled. They try at the bottom of 310 to show you what that's looking like in each of the 4 quadrants. And then on the top of 311, they finally get to applying all of that over into the curves like so. And then they finally get to giving you the picture of y equals sine of theta. All right, so I'm going to try to simplify all of their pages of explanation and say that if I start at 0, 0, and I know I have 2 sections in the positive and then 2 sections in the negative, I know that a standard curve will always take place in 4 sections. This last section should be the end of the unroll and be at 360 degrees. Now, sine curves always move, if they're positive, up first. If they're negative, which I'll show you in the next example, they're going to go down first. And I need a high point and a low point. And here, in a standard triangle, the high point would be a 1, 1. And so I know that my high point here is 1, and then that would imply -1 for the bottom. So these are the standard parts for any curvature until I start teaching you the changes. But for the basic ones, this is what you're always going to have: a 1 and a -1. 4 sections ending at 360. So I know, so I'm just going to do the dots, and my next one is going to go to the peak, then back to the center, then down to the low point, and return to its starting place. And so here is the basic sine curve. Now I said I'd show you negative sine of theta. Let me clarify one other thing. At the end, I will either find a theta or an x kind of being marked on the edge of the x line. And that's because I want to know in my picture what I was given in my equation, or vice versa. All right, so here is the -1. It's going to start at the center. It's going to have 4 sections. High point is 1, low point is -1. And then because this is negative, it's going to go down first. So I go down to the low point, return to the center, up to the high point, back to the starting place. And so that curve for negative looks like this. Now, bottom of the page, they give you forgot to label it again, cosine of theta. So it's going to have 4 sections, just like the sine does. Label it this time before I forget. This is still ending in 360 degrees. And I need my high point of 1, my low point of -1. So the major difference between sine and cosine is sine begins in the middle. Cosine either starts at the top or the bottom. Because this is positive, it's going to start at the top. And then that means it's going to go down first, low point, and then return to starting point at the top. So the cosine curve basically looks like this. And then y equals negative cosine of theta, exactly as you are anticipating. 4 sections, 360, high point, low point, and then because it was negative, it starts at the lower, goes to the center, top, and returns. And there's, oh, I missed a little bit, but you get the idea. There's your curve for negative. So now you see the basics for all of those. Now that you've got that, they throw in one other change in this lesson. And they say, what happens when we throw a number, theta, into the equation? Okay, so now my period, how many sections it does it in, is not changing. It's still 4 sections, ending at 360. My high point and my low point change with a number given in front. And so this one is now high point of 2, low point of -2. Sine starts in the middle. Positive goes up first. So the curve doesn't look like it changes when I'm doing the picture, but in reality, this is a little bit taller. And it's easier to see in the book where their curve is actually adjusting. Like this space of 1 almost looks like the space of 2, but I labeled it 2. So it should just look a little bit higher in the actual picture. Now, let's see, was there anything else? No. So in example 1, write the equation for, and they give you a sinusoid. Now they are showing it in more than one period for sure, but I see it starting here at the center, and I'm only going to mark the first 4 sections to get to the 360. And again, because these curves keep going, it is appropriate for them to give it to you, but you only need to look from starting place to repeating place. I see that the graph goes up first. So no matter what, I know that's what that curve is doing. So it's going to be a positive. It's going to have the word sine. At the end, it labeled a theta, which is why I need to have that. And I know it should be equaling y. And the only other thing I need to check is, what did they label my high point and my low point? 6 and -6. So to put the answer in its correct format, y equals 6 sine of theta. That's the equation. Example 2 does the same thing. Gives you a graph, asks for the equation. High point 3, low point -3. Ooh, this one they put in radian format, not degree. But a full circle for radian is in 2 pi. I see that this one started here, and obviously it's gonna do its curvature thing this way. And what did they label at the end? Oh, they labeled this one x. Okay, so we know we have y equals, the height changed to 3. This started at a low point, which means it is the word cosine, and instead of theta, it will have the x that was at the end. And because it started below, this is -3 cosine of x. If it started above, it would have been +3. So I hope that the last minute switch to radian here does not throw you off, but you're looking at what they're giving you, which was in radian, but of course my answer doesn't show any different that it's in radian or degree.